So first off, I'm a huge Raptors fan. I really believe in Spicy P and the gang are going to bring it home this year. Handful of Raptors fans in the audience. So I'm going to talk about JavaScript errors, kind of like going back to basics. How do the errors work? How do you throw them? How do you catch them? How are stack traces generated? That kind of stuff. Today I work for a company called Sentry. Sentry is a mostly open source tool that helps you sort of surface production errors from your many applications, whether they are anything from a Ruby app to .NET, even Unreal Engine. We kind of create these client libraries for pretty much every platform out there. Of course, really only care about JavaScript. If you are curious, it's very easy to get started, and Sentry is something that you can stand up yourself, so you can run the whole server, this whole infrastructure yourself, but you import a library, install this Vue integration, and you can just get up and running with an API key, and once you do that, JavaScript errors from your production websites will just flow into some dashboard where you get access to a stack trace and a bunch of fancy graphs that'll help you understand if things are broken. And then here's an example of what a particularly horrific web application might look like, and that's actually live Sentry itself. But I'm not here to talk about Sentry specifically. I'm here to talk about errors. So whether you're using an error monitoring tool like Sentry or any other, there's many tools out there that do this, or you're just kind of like looking at debugging output on the console, you can deal with errors that are very frustrating, that are opaque, and you don't understand what's happening. Maybe you've had this show up once, uncaught object. It's not very helpful. What's happening there? Maybe you've had an error that you've seen show up on the like in the console that has no stack trace, and that's very uncomfortable as well. Or worse yet, you've seen this one, which just is the string script error, which gives you no information, like something is broken somewhere. Best of luck. So in this talk, I'm going to talk about the error object itself, how you can extend that to create custom errors, talk about the stack property and the ways in which a stack trace is generated and ways in which it's not. What does it mean to throw non-errors? And then also, if you wanted to stitch up sort of error collection mechanisms and throw them to a server somewhere, we're going to talk about what that looks like too. So first off, the granddaddy error object. I don't know if people have browsed MDN and taken a look at the description of what the error object works, a couple nods. But this one sentence is pretty descriptive. The error constructor creates an error object. Instances of error objects are thrown when runtime errors occur. The error object can also be used as a base object for user-defined exceptions. That is a very tight 3 sentences. So it takes optionally a message, a file name, and a long line number, or whatever. Doesn't really matter. What matters is kind of how they get invoked. So let's take a look at this pretty simple piece of code. There's 3 functions that are declared, C, B, and A. A invokes B invokes C, and C invokes this function D, which doesn't exist. And this all gets kicked off at the very bottom with an invocation of the function A. If you run this, you get this sort of like stack trace output that looks like this. Uncaught reference error, D is not defined at C, B, A, and then the final line where everything was kicked off. It's very helpful, helps you understand the application control flow and what was happening when the thing broke. What you may not know is that if you did this instead of actually trying to call a function that didn't exist, but you just threw a reference error and gave it that same message because you were incredibly prophetic and you managed to write code this way, this actually produces the exact same result. So whether you're actually sort of invoking something that doesn't exist, or you just throw the sort of corresponding reference error yourself, as far as the console or like error monitoring tools are concerned, it's the exact same thing. You don't have to throw a reference error. Those are like some built-in errors that exist. You can throw the base error object itself, and that will produce a slightly different result. The stack trace is the same, but the message, the error class, or the error name has changed. There's really just 3 major components to the error object that I think are important. That's the name, which is sort of think reference error, value error, etc. The message, that's the message string parameter that we saw in the very beginning. And then the stack. And stack is actually a property on the error object where you get, function C, B, A, etc. These are all properties on the error object that you yourself can inspect. So if I have this code, which is, again, very similar to what we've seen, but instead of just throwing an error or calling a function that doesn't exist, I try to catch it which lets me sort of like inspect the error object, and then I console log out all of those properties. On Chrome, I get something like the following. So this is the name, which is the error class itself. The message is section 2 there, and then the third part is the stack trace. And this is sort of hyper-specific, but on Chrome, actually outputting error.stack also repeats the name and the message again for no particular reason. We'll talk about that later. There are a number of standard errors that are built into JavaScript that you could use if you really wanted to. Reference error was one that we saw. Range error. Internal error is one where if the sort of like internal JavaScript engine basically croaks, it'll bubble up and, I don't know, out of memory, something like that. Eval error only occurs if you have eval in like a global scope, just kind of helps you understand that. URI error is interesting in that it can only, or at least today, it's only invoked if you try encode and decode URI, those functions, with some parameters it doesn't understand. And I think that these are all of the ones that exist today. You don't have to be constrained to the error object or those like built-in objects. You can create your own custom objects. So in this example, I'm using the sort of like fancy class syntax to extend the error object. And it's not enough to just extend it. You actually have to do one thing, which is to set the name property equal to the sort of like name of the class. And that's because JavaScript can't actually infer what this is going to be. Who knows it's going to be minified. So you do have to do that work. And then you have to call the original error constructor. And if you do this and you throw your sort of custom error, you'll see that the name has changed. Right now this outputs super broken error. And the message is repeated and the stack trace is there too. You might be wondering, like, why on earth would I do that? That's not very useful. I agree, but there are a bunch of ways that you can sort of like encapsulate. You know, you don't have to be constrained to just using the 3 fundamental properties of an error. You can add extra metadata that might help debugging or make debugging easier for you. So, for example, if you're working on an API application, you might want to define an API error that exists, and that API error, in addition to taking a message, also takes like an HTTP status code. And then later in your code, you could sort of like try and catch some code, and you could explicitly look for instances of API error and then extract that like extra metadata. So this is just like, you know, you don't have to do this, but this is an example of how you can use errors in a way in which they will still, you know, bubble up and output the stack trace information, but you can attach extra properties if you wanted to. So error.prototype.stack is, I think, the most valuable part of the error object. Just to repeat, it's the part that tells you what your application was doing leading up to the crash. Right? So it includes every frame, what file it was invoked in, and what line number, and which column number. Stack traces are generated in a very specific way that might be obvious. I think to some would be non-obvious. If I call this code, it looks a lot like the one that we had earlier, but instead of like throwing the error or calling a function that doesn't exist, I generate an error object, and then I return it up the call chain until it's thrown by the, at the very top, throw A. Okay? If I call this code, what happens is this. The stack trace is generated at the point that the error object is created. It's not generated at the point in which the error is thrown. Right? And so that's like a really important fact, because it lets you one, when you sort of like are debugging things, it helps understand that fact will help you understand where a stack trace might come from, and it means that you can manipulate it in certain ways that could be helpful. So, for example, let's say that I did the following, where okay, now I'm going to call D that doesn't exist, back to that very first example, and then at the very top I try, and then I catch that error, but then I rethrow it. It's actually the exact same stack trace, right? So rethrowing doesn't really matter. But let's say that I do the following, and this is an example that I've seen a bunch of people do. We saw earlier how you can create your own custom errors. Some code examples I've seen do the following, where they try and they catch an error, and then like, I know that this is an API error, and so I'm going to create a new error object at this point in time to encapsulate that extra information that I've gathered, right? Maybe some of you use this. It's not unreasonable. But if you do that, what will happen is that you're effectively generating a new stack trace from that point in time. And you've clobbered the original information of where the crash occurred, which kind of sucks. So if you want to solve this, if you're doing this and you want to solve this, there is a way. which is you can just sort of copy that stack property from the original object that you're catching and copy it onto your new error. So in this example, it's just like the previous one, except I'm creating an error instance, and then I copy the stack property over, and now if I throw this custom error, it'll actually have that earlier stack trace, which is very helpful. Something in JavaScript that makes stack traces tricky is that we deal with a lot of asynchronous code, right? Whether you're adding event listeners, or you're using set timeout, set interval, or maybe dealing with a callback from XML HTTP request or fetch, you have code that executes later. In this example, where I have that cascade of functions ABC, but then I do set timeout, which sort of queues up a function to be executed on the on JavaScript's thread. If I try and catch this, all of that information about A, B, and C, and D is lost. I've more or less just kicked off a whole new execution context that is detached from A and B and C. So it's important to understand this when you're dealing with asynchronous code. However, modern browsers have sort of identified that this is a pattern that is very irritating, and they have blessed us with better console output that looks kind of like this. So if you actually ran this example in Chrome, and you looked in the console, specifically in the console, you will see the following. Chrome will sort of stitch together the fact that even though this is a sort of like new execution context, it will actually give us a stack trace that involves A, B, C. It will tell us that a set timeout was called, and then finally where the crash occurred. This is super helpful. One of the problems with it is that it only occurs in the console. So this is not actually like the stack property that exists on the error object. This is Chrome augmenting that error object with extra information so that you debugging like in the console has some more information to find the root of it. It means that if you're a tool like Sentry, you're doing your own error logging, you'll never see this output. Or maybe you will. One of the big challenges with working with stack traces in the error object itself is that it's actually like completely non-standard. So if you look up MTN and you basically read the following, which says, this feature is non-standard, it's not even on a standards track, don't use it in production, it will not work for everybody, there will be large incompatibilities. So, I don't know, at this point, like we all use it. If you're using any like error monitoring tool, we all use it. I think that the standard is that the property exists, but what that property is fair game. To put this in perspective, all the examples I've been showing you this far are from Chrome. But if I were to show you them from Safari or Firefox, they actually look quite a bit different. Earlier I mentioned that Chrome decides, like, this is just the stack property itself. Chrome actually sort of augments that with some extra information about the error name and the error message. The other browsers don't do that. The way that they actually present each stack trace is different. And this makes it kind of, logging this information is hard. If you're using a logging tool and you want to group like similar error messages from different browsers together, it's pretty much impossible unless you just hit it over the head with a whack of regular expressions. And it can change. There's no standard that says that this will be like this forever. And browsers have introduced changes that will kind of mess with things. So, some takeaways. Stack, it's generated instantiation when you create a new error. Rethrowing the same error will not generate a new stack. The first frame is always the topmost asynchronous execution, so keep that in mind if you're dealing with asynchronous code. It's just a string. It's not even like an object that you can inspect or anything. This is all string data, and it's non-standard. So raising exceptions. So we're focusing a lot on throwing exceptions, or like creating error objects. What does it mean to raise them? So in other languages, if you try to raise something that's not an error object, the act of trying to do so will itself create an exception. So in Python, if you try to raise a string, raise is the equivalent of throw in Python, you'll just get an error that says, whoa, exceptions have to be derived from base exception. What are you doing? Stop. If I try to do the same thing in JavaScript, what happens? Everybody knows. It'll just let you do it. So in this case, if I try and I catch this sort of thrown string, I just get the string oops. And this is really bad because all of that cool stuff we talked about earlier, the stack trace, the message, custom errors, all that metadata, it's gone. You don't know where this came from. That little 1 indicator is just to help you connect. It's not actually line 1. We don't actually know that either. Not a lot of people just throw strings or like non-error objects. That's pretty not normal. But an example that I think is more common is that people will reject promises in JavaScript using non-error objects. And that has the same effect, because if you are interested in catching an error and sort of like displaying its information, or you want it to bubble up to like a global error handler, the same thing applies. You have no stack tracer or anything. And what this might look like is, on the left, this is an example of rejecting non-error objects, and what it could look like if you actually did that practice on the right. That's why it's a green box. It's good. If you're interested, if there's one takeaway I can like give to you that would be useful, rather than me just kind of like rambling on about errors, is there are some ESLint rules that you can use in your own projects that actually force you to use these practices. So one of them is prefer promise reject errors. So that will just say, like, if you're working with promises, like, you must return an error object. Similarly, no throw literal will stop you from trying to throw some code, throw some objects that won't return stack traces, and you don't want that. A tip that I have for people, and again, this is from the context of like working on an error monitoring service where people email me all the time about like, why is there no stack trace? If you are dealing with a situation where you know that somewhere deep in your code, it could even be a library you're working with, that there is some object or some string that has been thrown, but you don't know where to find it. One thing that you can do, because we learned about how stack traces are generated, is that you can try and catch it, and if it's not an instance of an error, you can create a new error and pass that object into the new error object. And because we know that the stack trace is sort of generated at the time the error is created, you at least get a stack trace that leads up to the point in which you caught it. So it kind of is at least an initial clue for where this thing might be deep in your code. And this is a strategy that we use in our own client libraries to sort of at least give you a starting place. So non-error exceptions are caused when you throw any non-error object, and they make determining root cause difficult because there's no stack trace. Promises are a common source of them, and you can use the error object to add missing context when you don't actually have an error object. Okay, so this is like last thing, which is, we talk a lot about errors. This is all very handy, but what do you actually do with it? How do you collect them and put them somewhere? We've all seen a lot of examples with try and catch, where I try some code, it throws, I can catch it, and it's pretty reasonable that you can just have some code that makes an HTTP request to some logging endpoint that hopefully you've stood up that accepts some data, and you can JSONify the error object itself, put the name, the message, the stack in there. That can go to Splunk or something Elastic if you wanted to. But we know that JavaScript is very synchronous, and so this try-catch will not, you just can't start your application, do try-catch, and it's going to catch every error. If you have any asynchronous code, you have to try-catch every single one of those blocks. You're not going to do that. That's why JavaScript has a global error collection facility called window.onerror, which is very helpful. It has a whole whack of parameters, and that's because it's like really old. It's actually introduced it in 1997, so it's a really early JavaScript feature that we just kind of piled on. At the time, it just had message, URL, and line. And so the error object, which is the most valuable thing, you'll notice is the 5th argument. So that's just tacking on more things to make it more useful. And so if you have that error object, you can sort of listen to every unhandled error, and you can send that data somewhere. What's newer is window.onhandledrejection. This is kind of like onerror, but for promises. So if you're interested in collecting any place where you wrote some code and you have some promise that hasn't resolved, maybe because you're not catching like an HTTP request that failed or a fetch that failed, you can use this to handle them. The argument isn't an error, it's actually like a promise event object, but that promise event object has a reason property, and it is expected that reason property should be an error. So that's one of the ways you can do that. I have the browsers there on the right because until a month ago, actually Firefox didn't support this, but now it does. That's pretty cool. So like today, we're finally in this world where actually you can use all these error collection tools with full browser support, which is really great. Let's see. Oh, still got 10 minutes. Wow. Okay. Last thing, because this trips up a lot of people, is that if you start getting into error collection, you want to run it yourself, you hit this problem. Okay. Today we're deploying code on Netlify. We're pushing scripts all over the place. We're dealing with CDNs. And that creates a scenario where often the JavaScript file that you're loading isn't being executed on the same domain as your website is being run on. And in that situation, if you don't set it up carefully, and you use window.onerror to listen to an exception, you get the following: script error. So if you've ever seen this output before, this is the cause. The cause is basically because of the same origin policy. Same origin policy, if you're not familiar with it, is basically sort of this fundamental tenet of browser security that says, you know, content on one domain can't reach into another domain, or like one tab can't reach into another tab. If we didn't have it, it would mean that, you know, my personal website could just see if you were browsing to td.com and then just get your banking information, right? It doesn't let you do that. And the reason that that actually applies to this error, this sort of like global error handler, is that it's possible, it's conceivable that maybe you're loading a JavaScript file that is session aware, and if that script throws an exception that it could contain session-specific information, like what if you had an exception that said, you know, TD client, Ben Vinegar, account number 5763's password is X, and that's bad, that could leak over to other websites. So there's some things you have to do to make sure that doesn't happen. And that solution is CORS, or cross-origin resource sharing. It's not too bad. One, you just have to set an attribute on the script that you load that says cross-origin equals anonymous. And if you've seen this in snippets and you didn't understand what it's doing, it's basically a signal to the browser to say, hey, when I fetch this resource, like, don't send any cookies. This is an anonymous script. It's not session aware. So that's good. And then on the second side, if you are using a CDN, you have to make sure that the CDN has this header called access control allow origin, and that sort of says, hey, what origins, what domains are allowed to actually access this script? In this case, in this example, I put asterisk, which means every website. If you're curious, if you've ever used even like the global Vue file that's hosted on JS Deliver, where you follow like the Vue documentation, it's setting this header. It's sort of like, it's already aware of this CORS problem, and that's why you'll probably see examples that say, use the full example with cross-origin equals anonymous. So once you set that up, and you load the same file and you fire it up again with window.onerror, it works. Now actually that like error information will propagate. The reason I tell people this, even though it feels like an esoteric thing, is that if you don't do this, you just get this line script error, and it doesn't give you any signal for like how do you actually unblock it, which is very frustrating. It doesn't tell you line number or anything. So, wrapping up, I don't know, talked about a bunch of esoteric garbage. Errors are your friend. Use custom errors to add meaning to failures, so you don't have to be restricted to just the errors that come out of the box in JavaScript. You've seen how you can attach extra metadata that might help you like do some debugging. Keep in mind how stack traces are generated, so that when you're looking through your logs, you're trying to understand like, where is this? Where did it come from? Hopefully you know a little bit more about how it might look have that shape. Don't throw strings, please, objects or other non-errors. That makes everybody's life tougher, especially yours. And you can use global exception handlers. You understand how they work. So, once again, if you don't care for any of this and you don't want to deal with a lot of these details, I really encourage you to check out Sentry. It is a project that just gives you all these kind of like details out of the box. You don't have to muck around with a lot of it. Cool thing about Sentry, and why I don't mind standing up here and kind of like hawking it, despite the fact that I work there and I'm shameless, is that it is source available. So you can inspect, run, modify Sentry in your own company. If you work at a bank, you can put it there. It's totally free to use. A lot of people do. If you're interested, you want to ask me questions about what that looks like. We provide Docker containers. I'll be happy to answer any questions afterwards. I've written some blog posts on these topics before, and if I don't feel sufficiently bored, you can check out this blog post about like what the heck is script error, capture and report errors with window.onerror, post that I put on the Sentry website. My name's Ben. I go by Bentelgen on Twitter, and that's it. Thanks for listening. Cool.